itself.
So we
So
just add
see,
them
when you're
all up.
talking about circular motion, so there are
Okay.
few things that you have to remember. Okay. See, can you have uniform velocity in a
33
circular motion?
plus 40 plus 45
Why
plus
not?
49. Okay, I'm not writing all of these.
Because you're turning, you're not going in a straight line.
Say number
So basically, you're
of
saying the direction keeps changing, correct?
minutes
Yep.
If the direction keeps changing, then the
by
concept
number of
of
students.
constant velocity doesn't exist anymore, because velocity is a component which depends both on the direction
So
and on, oh, I can't write
that's
here. I
going
keep
to be
forgetting that every single time.
8
Okay,
plus
so
24
basically,
plus 33
because of
plus
that change
40
in
plus
direction
45 plus
continuously, you cannot have
49
constant velocity,
plus
but you can have uniform speed.
53 plus
Do you agree?
56
Because it
plus
covers
50
equal
plus
distances in equal
61
intervals of time. So you can
63
consider
plus
uniform
65
speed, but not uniform
so
velocity because
67 plus
of the concept of
69 plus
direction,
71 plus
right? So
72
when you're
73
talking about an
75
object moving in a circular path, so obviously it's gonna, so
76
one complete circle, what is the distance
That's
that
it.
you would have traveled?
Pray that we got all those numbers right, and we get
2 pi r.
divided by
2 pi
19
r.
is
That's nothing but the
55.684.
circumference of the circle. So that's basically the distance that you would travel. Let's suppose this guy here, if he finishes one full turn, basically you would have traveled a distance of 2 pi r, right? So 2 pi being the value that the entire
Minutes
circle is taking,
per day.
right? And r is the radius of that circle. Correct?
Yep.
Agreed to it? So that's nothing but the circumference of the circle. Now
Using the table of data,
I think we did
calculate the
discuss
mean
a
number of
little bit on
minutes spent per
centripetal
call.
acceleration
Was your estimate
earlier.
close?
Center seeking force and things like that. Did we discuss?
I feel like we did, like just a little bit.
Yeah, whatever we
Mean
little bit
number of
only. Let's
minutes
just
per
talk
call.
about it. What is centripetal? Let's like break this word apart and discuss.
What is
So
your
what does
estimate
this
close?
word
What does it
mean?
mean
What
by
is centri
using the
mean?
table?
It's center.
Something to do with a circle and center, right?
Mhm.
And petal basically means seeking kind of word. Okay, so centripetal is a force, or when you say centripetal acceleration, what you're trying to say, it's a center seeking acceleration. So any object which is going in a circular path would want to be caved into that path, right? So if I've this point P, right? Technically it should have moved forward like this in this path. Can you see that? Along this path. It should have gone like this, but instead what is happening, it's taking a curve and coming to point Q, right? Who's causing that curve? That curve is caused by the centripetal acceleration, because this object is tending to stay in a circular path.
We are supposed to do
Is that making
115.
sense to
Yeah,
you?
we are. So for
So
A,
essentially this is
is it
what we are
asking for the
doing here
mean
in
value
this
theorem?
entire topic. So
What was the mean value theorem again?
Hello.
I'm here. I just
So for mean value theorem,
laptop is going a little out of touch.
Okay.
So it is the same question, right?
no. I think what they're asking us is to use a different method.
Calculate the mean number of minutes spent per call.
That's B, then this is A.
Yeah. And for the first one,
Okay, what I was trying
For
to say,
A,
so
we
this
can
point is
say.
important. See, when an object
So
is
what was the
moving
mean
in a
value theorem again? It
circular,
just says that
in a
there's always
circle,
like a tangent
and
line,
its
right?
speed, okay, that is the magnitude of its velocity, right? We're not considering the direction,
and then the first
just
question
the
is,
magnitude of the velocity
estimate
is
the mean
constant.
number.
Then we said that then it
Mean
is said
number
that
of
the
minutes
object
per
is
day.
moving in a uniform circular motion. Always. And this is
Spent
again
per
important. The
call. Mean number
direction of
minutes
motion
per
of
day
the
spent per
object's
call, and this one
velocity
is mean
is
number of minutes
always
spent per call.
tangent. What does the word tangent mean?
13,
What is
blah,
a
blah, blah. In
tangent
problem
to a
13, you
circle or a
determine the
curve mean?
numbers of the class. Summarize how you calculated the average, blah, blah, blah. Use your process from
Like the
6113. What's the process? With blocks, build a
angle
tower to represent the size of your
block.
immediate family. As a class, stand in line by
See,
family size.
tangent
By
is a line
looking at the
drawn
classes, where you
such that
estimate
it
the
only
average number of
attaches or
tickets
it
each
only passes through
person
one
should
point on that
receive.
circle.
If you graph this data, what
Okay,
will the bar
so in
graph
this
look like?
case, now when you
Decide how to
draw the
redistribute
tangent,
the
see
cubes
this
so
is
that
the
each person has
tangent, this red
has the
arrow that you
average
see
number
here,
of cubes.
that's the
Cubes.
tangent,
How
and
many
it's
tickets
going
should each
exactly
senior
through
receive?
one point, and that point is P, right?
Yep.
So
The
tangent
bar
basically gives
graph
you the
and the
direction
which
of
the
the
data is
speed
given in tabular form,
factor
both
at
are
which
same,
that
right?
point is at. Got it? So for Q, you can see the tangent is different.
8,
See, the same
10,
tangent that you
24,
see here doesn't pass through Q
then
because tangent is
33.
only one's passable point. Okay, that's your math
Mhm.
definition for a tangent. All right. So that's what they're saying. The direction of object's velocity is always a tangent to the circle. Now, since the direction of motion is always changing, that means the object is always accelerating. Does that make sense?
Is it?
Why
Are
we
they
don't
saying that the
have
bar
constant
graph
velocity and
data
why we are
we have to
talking
write,
about a
and then the
circular
tabular
object
one
as
we
an
have to write, and
accelerating
then we have to
object?
check the mean?
Mhm.
See, these kind of questions can come as give reasoning.
Um,
Okay, why is an object in
The
circular
mean
motion
number of
considered
minutes per day
accelerating,
spent per call by
Mhm.
these
even if it's
students.
moving with the same speed,
8,
Yep.
right? So
24,
that's what we need to
37,
discuss. So the
33,
direction of the motion is
40,
always changing. That is the reason the object is always said to be
46.
accelerating. See, this is very specific
I don't know
only
what's
for the
asking.
circular paths. Okay,
What process are they asking?
clear on that?
Okay, in
Now,
the process of above, they say with
did he
blocks,
do the
build the
derivation
tower.
of
Into
the
your class
centripetal
by size.
acceleration?
If you look at the graph,
In the first question, use
you
the
determine the mean
process
number of tickets of your class. If you
Okay,
graph
even if
this, well,
he's not done, we'll
decide how
just
to
quickly read through it
redistribute each
and we'll
graph.
do it. Okay, if you have any doubts, we can discuss that.
How many
Now,
tickets should
this
each
is an
senior
important figure,
receive?
so pay attention to the
Each
figure.
student receive.
So you have
essentially.
the object initially
Okay.
at point P, moving with the
So
velocity
if each
v1.
student
That
should
point
receive
is actually in a circular
that
path, so
many
eventually
tickets.
it comes to point Q with another velocity v2. Obviously, v1 and v2 are not the same, as in magnitude can be the same, but the direction is not the same. Okay, so speed of v1 and v2 will be the same, but the direction is not the same, so velocities are not the same. Okay, R1
I think
is
they're
the
just telling
distance
us
from
to
the
estimate
center
just
to
by
point
looking at
P,
it.
and R2 is the distance
Looking
from
at the
center
graph,
to
maybe.
point Q.
Because that's the
All
quote
right,
unquote
the
process
distance
that they
between
used
point P and Q,
before.
it's a
No.
chord which is marked by delta R, that is the change in the radius value.
By
Okay,
looking only in the
this
graph, how
tiny
we
value,
will find it.
and theta R.
Mm.
Any
And
idea what this is?
when I see the graph and the tabular form, the first one is given 8, so that is almost close, that is right. Then 24 is also that.
It's the
Then the
angle
third student
created.
is 33.
How much is
Then the
the
fourth
angle
student is
swept
40.
from
Fifth student
point
is
P to
45. So
point
graph
Q?
is also showing that.
Okay,
That is the
so
thing.
that's what they're saying. See, shows how the velocity of
thing.
an object changes when it
Yeah, most of
undergoes
the
uniform
numbers.
circular motion. Now, as
What
the
is the
object
mean
starts
number of
moving
minutes
from
per
point P
minute
to point
was
Q,
spent
its
per call.
velocity changes from
And this
V1
is
to V2.
calculate.
Okay,
Okay,
since
estimation
the
means we have
direction
to
of
just see
acceleration is same
and
as the
means
direction of
assume,
change
right?
in
Something like that.
velocity, we can say
Yeah, so
delta
we
V
can
is equal
assume
to
that it's
V2
somewhere
minus
around
V1.
like 55
Right? The change in
or
velocity is
around
nothing but
60-ish. Because
this
like if
is your
I'm just
simple
using
vector addition
my
that we are doing.
eyes, I'm assuming that
Right? The
the
resultant
center
is
is
nothing but
somewhere
V2
around
minus V1.
the
All right.
mean. Okay.
Now,
Yep.
what they're trying to
Most
say
of
is
the
vectors
values are
and V1 and V2 are subtracted graphically under the circle. So this is just to understand how the relationship between V1 and
I don't
V2
know.
is.
I think I'd place it
Okay,
around
there's
each.
nothing much to worry about here. Okay, now R1 is equal to R2
I
because
don't know
both
how
of
to
them
answer this, so I'm just
represent
gonna
the
put
radii of the circle, and you know the radius of the circle will be the same
One is
irrespective
nearby
wherever you
80
draw it from the
and
center.
the smallest one is
Agreed?
nearby 10.
Yep.
Okay,
Right.
so
So
from this
we can, but
notice,
see the
from
graph
because
is
R1 is equal to R2,
so
this becomes
75.
an isosceles
So
triangle,
76
right? Two
plus
sides are
8.
equal.
84.
Correct?
84 divided by 2 is
So
just
this
42,
statement
which
is
is
okay
nowhere
for you. Why
close.
it's an
So
isosceles triangle?
And if you take 10
Yes.
plus 80,
Are you
that is
comfortable with
45.
this statement as well? Why? Can you see that there
It's
is
100%
lines
velocity.
outside? The lines indicate just the magnitude. Okay, it's
It's
not
an estimate. It
V1,
doesn't need to be that
velocity
close.
V1 is equal to velocity
It's
V2.
better to just
It's the
move on.
magnitude of velocity V1 is equal to magnitude of velocity V2
What is it
because
total?
speed is constant.
Right.
I thought it would be the absolute value. I thought that's
So
what
we
it
just
was.
add them all up.
Absolute or magnitude in
Okay.
this case. Basically, we are only considering the value and not the direction in which it's
33
moving. That's the whole idea.
plus 40
That's what
plus
absolute also
45
does, right?
plus
We
49.
don't
Okay, I'm not writing all of these.
consider the negative sign. We just consider the mod of that value, right? Same
Say
thing.
number of
Okay. Now,
minutes
again, what are they saying? Since V1 is the
number of
magnitude of
students.
V1 is equal to magnitude of V2, that means this one is equal to this one,
So
right? So that means the length of
that's
V2 is
going
the
to
same as
be
length of V1.
8
Therefore,
plus
this also
24
becomes an
plus
isosceles
33
triangle.
plus 40 plus 45 plus
So that's what they're trying to tell.
49
Now they're saying
plus
R1 is
3 plus
perpendicular to
56
V1 because V1 is the
58
tangent
plus
drawn at this
61
point. Tangent is a perpendicular.
63 plus
Similarly, R2
65
is perpendicular to V2
so
because V2 is the
67 plus
tangent drawn at
69 plus
point Q,
71 plus
right?
72 73 75
Now, next we have, so can you see that these two
76.
triangles are similar to each other,
That's it.
right?
Pray that
This
we
is
got
an
all those numbers
isosceles
right,
triangle.
and
This
we
is an
get
isosceles triangle. You
divided by
have shown
19
that
is
this R1 and
55.684.
V1 are perpendicular to each other. Similarly, R2 and V2 are perpendicular to each other. So by that logic, you can say that theta R is equal to theta V. That is change in the radius. Okay, the angle swept by the radius will be
Minutes
equal to the
per
change in the
day.
angle swept by the velocity vector. Okay, see, because the angle between the corresponding members of sets of perpendicular lines are equal.
Using the table of data,
Alright.
calculate the mean number of minutes spent per call.
Now,
Was your estimate close?
basic idea is you're showing that this triangle and this triangle are similar to each other. Okay, now from similar triangles, what property
Mean
can you
number
get?
of minutes
Your
per
map.
call.
From if the two triangles are similar, what
What
can
is
you
your
compare?
estimate close? What does it mean by using the table?
The sides can be compared.
Yep.
The ratio of the sides should be equal, right? Because you're saying that these two triangles are similar.
Table of the data,
So that's why you're
calculate the
saying
mean number
delta
of minutes
R by
spent per
delta
call.
V, or rather you can say that delta R by R. Okay, this side upon this
So
side
that is only
is
what we
equal
have
to
found out
delta
this, the
V
mean.
by V.
That's what
In
I'm
general,
wondering.
either it is V1 or V2, it doesn't matter because both
Calculate
of
the
them
mean
are the
number of
same.
minutes
Similarly,
spent per
R1 or
call.
R2 doesn't matter. Both of them are
That
simply
is
R.
around
Right?
55.
See, that's what they're saying. The ratios of the corresponding sides